Hello everyone. Today let us revisit the concept of polynomials of class 10. Let us begin with the definition of polynomial. Polynomial is an expression consisting of variables and coefficients. The important thing here is that the exponent of the variable should always be a whole number. Here are some examples of polynomials. Now let us see why some of the expressions are not polynomials. Here are three examples of such. In the first case, we see that the power of the variable is negative, and in the second case, we see that the variable is in the denominator, and in the last case, we observe that the variable is inside a radical, indicating a fractional power. Here in this case, it is to the power of 1 by 2. Now, let us classify polynomials based on the degree, starting with degree 0, which is our constant polynomial. Like an example, number 3. A polynomial of degree 1 is called as linear, of degree 2 is called as quadratic, and finally the degree 3 is called as cubic polynomial. Let's look at our next concept, which is geometrical meaning of zeros of polynomial. Zeros of polynomial are basically the point where the graph and the x-axis meet, which we call it as x-intercepts. Here are two examples of the same. In the example on the left, we see that the graph meets the x-axis at 2 points. So I say that the graph has two zeros whose values are -1 and 4. And on the graph on the right, we see that the graph meets the x-axis at 3 points. So I say that the graph has three zeros which are -1, +1 and 2. Let's see some more examples of the same. Starting with the left hand side here, we see that the graph doesn't intersect the x-axis at all. So I say that the graph doesn't have any zero. And on the right hand side, the graph just touches the x-axis, concluding to be having only one zero, which is the point 2. Now let us see how to find these zeros of a quadratic polynomial by factorization. We know that the standard form of a quadratic polynomial is ax squared plus bx plus c. Let us take an example of such. Now, to find a zero of the polynomial, I need to equate the given polynomial to 0. Now, I need to look for a number. Which is, when I multiply those two numbers, I have to get 6x squared, and when I add those two numbers, I need to be getting the middle term, which is plus 5x. In this case, plus 3x and plus 2x are the two numbers. So, in the place of plus 5x, I write plus 3x and plus 2x. And I continue to solve them, and I get my values of x as -3 or x is equal to -2. Now I call them, one of them as alpha and other one as beta. Now let us see what is the relation between these zeros, alpha and beta, with the coefficients of quadratic polynomial a, b and c. If a quadratic polynomial is of the form ax squared plus bx plus c, and if its zeros are alpha and beta, we have two relations. One is the sum of the zeros, which is -b by a, and the other one is product of zeros, which is c by a. Let's verify this through an example. We'll take the same example which we took it earlier, which is x squared plus 5x plus 6. Here we see that a is equal to 1, b is equal to 5 and c is equal to 6, and the values of zeros as we had got earlier, which is alpha is equal to -3 and beta is equal to -2. Let's verify our first relation. Substituting the values of the zeros and the coefficients, we get -5 on both the sides, verifying our first relation. Moving on to our second relation, we substitute the values again to get LHS and RHS equal. This is an example to verify the relation between the zeros and the coefficients. Next, we go into the opposite process of what we are doing. Now, with the help of zeros, let us find a polynomial. Okay. Now, if alpha and betas are the zeros of the polynomial, the standard form of writing a polynomial is x squared minus sum of zeros into x plus the product. So let us verify this with an example. Here I take two zeros, x is equal to 1 by 4 and x is equal to -1. So as I know the standard form, I substitute the values, I add the two zeros in the middle section, and I multiply the two zeros in my last section, giving me the answer as x squared plus 3 by 4 into x minus 1 by 4. Now we know that for given two zeros, there exist infinite polynomials which passes through those 2 points. Hence, there will be a multiple k to get a different polynomials. Here, I take a suitable value k as 4 to get my answer as 4x square plus 3x minus 1. Now, in some cases, we observe that sum of the zeros and product of the zeros are directly given. In that case, there is no need for us to add or multiply. Directly, we can substitute in the values and get our final answer. Now, let us move on to division algorithm for polynomials, which is p of x is equal to g of x into q of x plus r of x, which is simply dividend is equal to divisor into quotient plus remainder. Here, we have two conditions to follow, which is either the degree of r of x is less than g of x, or if the value of remainder is 0, then we can conclude that the g of x is factor of p of x. Now, let's take an example of division of two polynomials. Here, 2x square plus 3x plus 1 needs to be divided by x plus 2. Here I observe that by taking the quotient as 2x, I would be getting 2x into x as 2x square and 2x into 2 as 4x. My next process is subtraction. That is, I change the sign. Then my answer would be minus x plus 1. Next, my suitable quotient would be minus 1, giving me minus x minus 2. After subtracting, my answer would be 3. This completes my division process. Now, let us verify my division algorithm, which is p of x is equal to g of x into q of x plus r of x. As I substitute the values and solve them, I observe that the values of LHS and RHS are equal. Now, let us take a different type of example to understand division of polynomials much better. Here, we are asked to find the remaining zeros of a polynomial of degree 4, of which two zeros are given to us. We know that a polynomial of degree 4 will have at most 2 zeros. Now, with the given 2 zeros, which is minus 2 and minus 1, let us form a polynomial, which is g of x is equal to x square plus 3x plus 2. Now, let us consider our given polynomial 2x power 4 plus x cube minus 14x square minus 19x minus 6 as p of x and continue our division. On successful division, we would get our quotient as 2x square minus 5x minus 3, which we would then factorize to get our two values of x, which is x is equal to 3 and x is equal to minus 1 by 2. These are my remaining 2 zeros of the given polynomial. So at last, I would like to conclude it as the zeros of the given polynomial are minus 2, minus 1, which is already given, and 3 and minus 1 by 2, which we just found out. I hope this video was quite helpful. Thank you so much.